On? Too much on. Okay. So let me start again for people in the world to know that I'm just saying thank you for the organizers to let us be here, especially Rafael, and enjoy the place for sure. You were doing this and we also. And if you have not noticed, I changed completely the title, so it's not like Constantino that is the same talk but with a different name. It's really a different talk. I would like to advertise the colored graphics and things like this, but I think this one will be more interesting. This is really fresh news. And it's a joint work with Rafael Rabelo, and since 2 days ago by the beach, it can have become a joint work with more people. So let us wait for this. So this is the symbol of my new institution. So in the end, I'll talk a little bit more about this. This is the national collaboration. Our group that used to be based in Minas Gerais now is a non-local group spread around the country. And those are institutions for money. So this used to be an important institution in Brazil. Nowadays it's a 4-level rank after some guys took the power. And this is still an important money institution in the state of São Paulo. So this is actually good news in the sense that now I am in the state of São Paulo. And this is a necessity for the moment. So let us talk about the split of contextuality and non-locality that appear to be monogamous, but let me introduce things slowly. So let's go to the top of mind that we relate to non-locality, the usual CHSH scenario. And you all know the situation that they have one system in principle that splits into 2 parts, and then 2 possible choices for each of them, each of the choices with 2 possible answers, and we are considering this kind of marginal scenario. If it can be explained by local hidden variables, you say it is classically understood. And after fine, we have also understood this as a kind of top-to-bottom approach. If you have a complete distribution of probability for all the possible cases here, that marginalized gives you the original marginal scenario you have, then it's also a consistent thing. Okay, so the top of mind of contextuality is 5, this pentagon scenario. Also the same idea that you want to recognize if you can understand things as non-contextual, if you can start from a hidden variable lambda and defining values only on x1 for each part. Okay, so after Constantino and co-workers, we know that there is a fine theorem for the same situation. And in both cases, we can proceed as usual, as at least usual before other methods being used that were prepare inequalities under that assumptions of being or local or non-contextual theories. You choose wisely states and measurements, and then you violate those things with quantum theory. And then you are happy to understand that those are special characteristics of quantum theory, or not necessarily quantum theory, but that those are distinguished characteristics of classical situations, and quantum theory does not obey it. Okay, 3 years ago, you were in that city, very close to here, and I can see smiles on the auditorium, just remembering this, and the majority of the people in the photo are also smiling on the photo. But then, during this interesting meeting, one of the interesting discussions was exactly about monogamy of those 2 things. So what's the idea? What's the question? Can we have both violations together? In which sense? Can one experimentalist in her lab find violations of contextuality, so in this special case of the pentagon, and using the same resources, so essentially the idea, since we know that compatible measurements will not help in having CHSH violation, the idea is essentially if she takes A1 and A3, for example, and take it jointly with B1 or B2 in Bob's part, if they can have a CHSH violation with the same data, okay? So she collects in her lab, he collects in his lab, but they know how to synchronize those things. And with the special data that comes, for example, from A1, A3, they correlate it with B1, B2, and verify if there is a violation. And essentially, who showed to us what was happening in those cases were those three guys, two of them present in that meeting. And you can see here they were discussing exactly those situations. And they say, and they teach us that, no, in that case, if Alice can violate KCBS, no CHSH violation. Also, if they violate CHSH, no KCBS violation. So, impossible to have them joined. And even for reasonable GPT, it's not generalized probability theories. It's not only a quantum thing, but a thing of non-signaling. Okay. And they suppose this was a completely general thing, and indeed the passionate discussion was about this belief of generality of the result, that there should be this thing that they like to call monogamy inspired in the idea of entanglement monogamy. So the idea was essentially that one, that if you gain in one, you should lose in the other, and how things will behave. What's the news? And really, we only realized this less than a month ago. No. As usual, the explanation is much simpler than you could try to imagine, and we should have arrived at it 3 years ago. But sometimes it takes time. So what I will discuss now is exactly why we don't have this, and give some good and simple, I believe simple, examples for this. So only one more ingredient that has already appeared during this conference, the Peres-Mermin square. So this set of 9 possible quantum observers, quantum operators for a 4-dimensional system, for a Q-quart. So the special property here, each of them, if you take a column or a row, you only have compatible things. So for this row here, and indeed for all the rows, if you multiply them all, you got the identity. For these 2 columns, the same. But if you multiply this last column here, got minus the identity. So this is a parity proof of contextuality. And the most interesting point in these kinds of proof, in these parity proofs, is that they are state independent. It doesn't matter which state you use for verify contextuality here. And you can translate it into inequalities that are always violated. Okay? Non-contextuality inequalities that are always violated. And if we think experimentally, what's the scenario for having a violation like this? Since we need to make 3 measurements, or the 3 that are in some row, or the 3 that are in some column, essentially you can consider this box view as a first choice. Y1 is made by our guy here. And then this defines one of those 9 possible measurements. Then he chooses another compatible one. So he has to choose some other measurement that is in the same row or in the same column. And after this, he has no choice anymore. The third one is already defined, so Y3 is just the other one that is missing to complete or the row or the column. No diagonals to play tic-tac-toe, just rows or columns. Okay. As we have said before, in that 2 cases, we were discussing inequalities from our local or non-contextual theories, wise choices of states and measurements. What's changing now? If we take a state-independent non-contextuality proof and translate it as an inequality, no choice of state anymore. You can do with whatever state you want. It's only a question of wisely choose measurements, wisely choose what, obey what they need to obey. Okay, so you can use it to get local contextuality together with non-locality. So probably the most important slide of the talk is this one here, where what we can see in that specific slide. This part here is exactly what I described as a Peres-Mermin test for Bob. In that part there, we have the same situation for our friend Alice. But if you focus only on the gray part, you have the usual CHSH scenario, or something analogous to a CHSH scenario. Bipartite Bell scenario, not exactly CHSH, because there are many possible choices. There are 9 possible choices for X1 and Y1. So just remind you, each part will have a Peres-Mermin square like this, and the system, the experiment itself would run simultaneously on both labs. So they receive the quantum system, make a first choice independently, each of them, X1, Y1, register the result. After this, they can continue on their Peres-Mermin square in the same way as before. So given the first choice in each side, now decide for some other measurement that is aligned, or in a column, or in a row. The third one is already defined, but you go there and measure to check the inequality. And if we pay attention, for example, for these 2 pairs here, we can see that here we have sigma x and sigma z only acting in the first qubit of this Q part that Alice will play. So we consider, since the structure of these squares, that the Q part is viewed as a pair of qubits in each side. And here you also have sigma x and sigma z. So we can use it to make the CHSH violation. So all of you played well with those tricks in old times and say, no, but Bell violation is not with the same measurement. But come on, this is for singlet. We can simply make a rotation in one of the parts, and we get for these guys here with this other state, this rotated singlet. It's one side rotated, essentially to compensate this. And you can simply consider this is a choice of axis. And here, the important part, if we only focus on those guys, is the first pair of qubits. So you have a second qubit for each part that they take from the garbage to make Marcelo happy. But you can also consider, as I showed here, to have 2 copies of this same state, and then you can have Bell violation with these 4 guys, and another Bell violation with that other 4 guys here. And even the news are better. In the Peres-Mermin square, everything that is not aligned anti-commute, so you can play, and it depends on the states that you choose, but you can also make other kinds of Bell violation, or other kinds of CHSH violations with those guys. So this is essentially the killing example. So no monogamy at all. So go to Mateus. Thank you. This was the, how are the words for in English for batom na cueca, or something like this. But okay, exactly. And this is the central result. There are physical situations where you can have both non-locality and local contextuality. And we can take another look at this. We can think it more abstractly and what we are really playing about. So if we go for this complete organized scenario here that we like to see as a generalized Bell scenario, not exactly in the sense most common nowadays, but in another specific way, that here we use this semicolon just to divide the 2 parts, but we have those 6 questions that are listed here, the respective 6 answers, And this experiment gives to us this list of probabilities, or at least is our description. It gives the frequencies only. Okay, and essentially we are doing these three questions. So those three things here are marginals from those things that we are considering that are or not marginals from another larger thing. But here, if you add in all A2, A3, B2, B3, you get this distribution here. And this is a regular Bell distribution, and you can make the question, is it local or not? If you add in all the B's, you get this other marginal that only refers to the lab of Alice, and you can ask if it's non-contextual. And the same for the Bob's part. You can consider only his lab and ask, okay, is this non-contextual? And this is the Amy Winehouse example. No, no, no. Okay? So another interesting way of seeing the same thing. We use this notation here for these A1, A2, A3, X1, etc. So these vectors are, in this example, just the contexts, the local contexts that are being analyzed. So this is the necessary generalization for Bell scenarios that we play with. And then, for those guys, you can do that three marginals that we already discussed. You can only look what happens with Alice, only what happens with Bob, and what happens with their first choices. So this non-vector A is just a number, just the usual one. Okay? Then the questions that we are making there is, do we have a complete distribution? So now capital A is the set of all, capital X is the set of all possible values of this small x here. This is a set in it, an ordered set, just for making the notation clear. But the essential question is this: does it come from marginalization of a complete distribution? And then you can do the same question in the other side. And of course, you can do the analogous question for the joint distribution, for the AB distribution. But there is even another question that can be made here. So you can positively answer all those questions, but this is another question. Do you have some larger distribution that includes all the correlations that are present in those fragments that we are analyzing? And of course, if this question is yes, then the other, if you marginalize from this, you get positive answers for all the others. But this is something that we must investigate better and understand better. So some more examples, just to not appear that is something related necessarily to Peres-Mermin. So essentially we took another state-independent proof that is U and O. Sorry, I should have included the reference here, but I forgot. And I will not give the details. Some of you know, the ones that do not know, it would take more time for me to explain than is allowed and then it's practical. But it's simply another state-independent proof that comes to an inequality that's slightly violated, and then after this you can have better inequalities and also things like this. But then the central idea is again to have two of these. And okay, we took two of these, but since Q-treats are sufficient, you can even play with other proofs in the other side, or simply you can be happy in having one like local contextuality only in one side and the other just play to make Bell violation. And so this is another example, and we are plenty of them. And here is one example of Bell inequality, of CHSH inequality that can be violated from those vectors that I put in the previous slide. And another example, I also should have included the reference here, but this comes from the same trio that appeared in the photo, Pavel, Adan, and Dago. And here they have what they call almost state-independent proofs of contextuality. So this you also can translate in terms of inequalities that are violated from almost all quantum states, but given a quantum state, you have to choose wisely which observables you use or which projectors you use to implement this thing here. Except by the the totally mixed one for Q-trees. So this you can violate with Q-trees also. And again, you can do the same stuff, and I'll not take more from your time for this. So, as approaching the end of the talk, we show that monogamy is not a general rule. So, the way to do it can be first understood as combining state-independent contextuality, but it's not the only way. This is the importance of the last example. There are also non-sick examples. And future, we need now to understand better and to find the simplest scenario where this happened, but the difficult part in saying that something is the simplest is that it depends on the simplicity criterion that you use. So if the simplicity criterion is related to dimensionality of the quantum system, we already have, if you want to have local contextuality in both parts, dimension 3 is the minimum necessary. And you go, for example, for this U and O. You can also choose the almost state-independent and things like this. Or, if you really want what's the smallest dimension possible, a Q-trit and a qubit. You just do local contextuality in one side and non-locality between them two. Number of measurements is another good criteria for simplicity, and this we don't have the answer yet. We have to continue searching. In experimental terms, it's also an important question. What's the most simple to make in a lab? And of course, this depends on which lab. I'm sure Fabio considers photons simpler than atoms, especially because he can do photons, and atoms would be harder. And of course, other details in dimensions and etc. and number of measurements are also important tasks. Okay, but don't take the wrong message. We are only saying that it's not a general thing. It's not that it's impossible to see non-locality and contextuality together. We even believe that it's very common, that if you go to larger scenarios, you will find both together in many cases. But if we take a look at, and we tried some examples before, then there are some trade-offs. So it's yet an interesting thing to search for where you really have some generalizations of that special case of monogamy of the simplest case in each side. So it's yet an interesting area to invest. And to take the last minutes, many people asked me where I was, how life is, and things like this. So just a sketch. Here we are in this beautiful part, essentially the most close one to Europe, and one of the most close to North America also. We used to be at Belo Horizonte, that is the state of Minas Gerais. Now I'm a little bit to the south, in Campinas. And for people interested, Paraty is just by this corner here. So, and Rio, for the ones that could not localize, is also in this green, this dark green part, and etc. And in the times of school, geography was the best partner of history. So this is a picture of our group at Belo Horizonte almost 3 years ago. This bunch of people where you can recognize some of them in the cities, some of them only in other photos and etc. Some of them already gave talk here and need to rush, and is a co-author in this paper. So a little bit after, 1 year after that other, and 1.5 years ago, these were the terráqueos, as they like to call themselves. Many of them already gone. Some of them are still around Belo Horizonte and sometimes in Campinas, like Tassis. And essentially the message is that I went to Campinas, Rafael also went there first as a postdoc, now he's waiting for a position that he's already approved, but bureaucracy is also difficult. And the group is growing, so whoever wants to join or to visit or to etc. is very welcome. With this, I thank your attention. May I chair?